everyone. This video will cover the first two examples of lesson 2.1 from Algebra 2A. And as we work through these examples, I will be leaning on that vocabulary that was covered on the first page of these notes. So if you haven't taken the chance to copy those definitions down or watch that video if you need to, please take a minute to do that before you dive into this video. So in this first example, we're going to build our own function. All right, we talked a little bit about function relationships. We're going to build our own function and then utilize some of that vocabulary, the independent and dependent variables, domain and range, that kind of thing. So the cost of renting a car is $35 a day plus 40 cents a mile for mileage over 100 miles. And we'll dig into like how to actually write the equation and all of that later on. But first, I just want to know, is the cost a function of mileage or is the mileage a function of cost? And really, this is going back to, if you look at that previous page, at the bottom here, we talked about this statement. The dependent variable is a function of the independent variable. So what we really need to decide is our two variables here are cost and mileage, and we need to decide which one of those depends on the other. So does the cost depend on the mileage or does the mileage depend on the cost? And in this case, I would say the cost depends on the mileage. The mileage is going to be independent because that's what you can control, right? You can control how much you drive the car. And then the cost would be your dependent variable because the cost depends on how many miles you put on the car, okay? So based on that relationship, we want our dependent variable to be a function of the independent variable. So this first sentence where I labeled the variables, that's the one that's correct, okay? So I would say the cost is a function of mileage. That also means that the mileage will be our input. So when I write my final equation, we're going to write it so that I can plug in any mileage I want and the equation will spit back the cost for me. Okay, so identify the independent and dependent variables. I really felt like we had to do that to be able to answer that question up above. So we already did that. Independent is mileage. And dependent is cost. Okay, so state the domain and range of this function, assuming we are renting the car for only 1 day. So really what that does is this $35 per day thing. I don't have to worry about that a whole lot because I'm only going to do 1 day. So basically I'm going to pay the $35 fee once and then 40 cents a mile. So when I'm asking you about domain and range, sometimes people get this question mixed up with this question. Domain is not asking you, the independent variable is mileage, that's your x. So I wouldn't want to say the domain is the mileage. The domain is asking you for the possible values of the mileage. Okay, what things could the mileage be? And so that's really asking what numbers are reasonable to be able to plug in for how much you're going to drive this car. So for the domain, really, I just want to say that mileage has to be something greater than 0, right? I have to drive more than 0 miles. There's really not a limitation here that says I can only drive this many miles. I'm just going to be paying for it no matter what. So I'm going to say that my mileage has to be greater than 0. And I can have mileage that's, 2.5 miles or 300.4 miles. I can have decimals of miles as well. I guess the rental company would decide if they were going to round that or whatever. I don't know. But I think it's totally suitable to just say our only restriction on our mileage is that it has to be greater than 0. Okay. As far as our cost goes, for our range, let's think about what our lowest cost could be. Well, I can't get away with a cost of $10. Think about why not. If I have to pay this $35 fee no matter what for renting the car for the day, even if I drove that car 0 miles, even if I rented it and just let it sit there on the parking lot, I'm going to be paying that $35. So my cost at a minimum is going to be $35, okay? It could go up forever depending on how many miles I drive the car, but I'm going to say that my cost has to be greater than or equal to 35. I guess we could debate whether or not this one here should have an equal to. I don't know if it makes much sense to rent a car and drive it exactly 0 miles, but I mean, technically you could. So that's what I'm asking when I ask for domain and range. I'm not asking for these vague kind of category headings. I'm asking for what values make sense for those headings. Okay, so now let's list 3 ordered pairs that belong to this function. So what I'm looking for when I say ordered pairs is pairs of mileage and cost that go together. So I want to pair a mileage with a cost, and I'm doing the mileage first because that's my independent variable. Okay, so we're just going to make up some mileages. That's a weird word to say, but and figure out what the cost would be. So if we were in class right now, I would just be asking you to kind of shout out some mileages here. But let's go for that 100 miles. Let's say we're going to go exactly 100 miles. So one of my pairs would be 100 miles. Okay. And this says I only have to pay the 40 cents a mile if I go over 100, right? So technically, if I drove exactly 100 miles, I would only be on the hook for that $35. Which actually means we could make this really easy, right? Because if I go anything under that 100 miles, my cost is still just going to be that $35. So I could say, 25 miles would cost me $35. Okay? But we're going to do one where we actually have to do some math here too. Let's say that I'm going to drive this car 500 miles. So if I'm going to drive 500 miles, I'm paying 40 cents a mile for the mileage that goes over 100. Okay? So I'm not paying 40 cents for the whole 500 miles. I'm going to take that 500 and subtract off the 100. I swear there's a reason I'm doing this in a calculator and not just in my head. Okay? And then I'm taking that and multiplying it by the 40 cents. And then I'm taking that and adding it to the $35 per day. Okay? So that 500 miles would cost me $195. Okay, so there's my 3 ordered pairs. You could make up anything you wanted here. Okay, if I just asked you for the ordered pairs, you can make up whatever you want. Think about this for a second. Is this an issue in terms of being a function? Is this thing still a function? Hopefully you're thinking yes. This is still a function. It's okay for those y values to repeat. What would be a problem is if I had one customer that drove 100 miles that I charged $35, and then I had another customer drive 100 miles and I charged them something else. That's when I would be in a situation where it's not a function. But as long as every mileage comes up with a unique cost, we're good to go. Okay, so the next question is asking us to actually write an equation for this thing. And the reason I put all of this on my screen so I could refer back to it later is sometimes I think that's an easier way to go when you're trying to write an equation, is if you work through it with actual numbers first. So write an equation to express the relationship between miles driven and cost of a one-day rental. Well, our equation is going to start with our dependent variable. Think about all of the equations you ever write. Don't they usually start with y? Y equals, that's your dependent variable. So we're going to say the cost equals, okay? And then let's think about what we did. That 500 represented M, right? That's my mileage. The first thing I did with it is I subtracted 100 because we have to make sure that we're not going over 100 miles. So I'm going to say, I'm going to take M and subtract 100. And then we multiplied by the 40 cents a mile, right? So I'm going to multiply by 0.40. Okay. And then I'm going to add that $35 a day fee. So this would work perfectly fine as an equation. I'm going to talk about a couple of things here because this is kind of a complicated situation to do this for. I'm going to clean this up a little bit. The nicer way to write this algebraically would be with that 0.40 first. So I'm going to write 0.40 times M minus 100 plus 35. Okay. If you can come up with that equation, I am quite happy for our first day of Algebra 2. But there is a slight issue here. We said that our domain for mileage was anything greater than 0, right? And so if I plug in something that's smaller than 100, if I were to plug in that 25, I'm going to get a negative number here. And as nice as it is that they don't charge us for those first 100 miles, they're certainly not going to pay us to drive the car, right? We're not going to have negative money to work with. But that's exactly what would happen here if I plugged in the 25, is I would get a negative value here and I would actually bring down that $35 cost, okay? So this equation that we just wrote technically only works if m is greater than 100. So that's when we kind of put this clarifier here at the end. This is for m greater than 100. And then what we should do is write an equation for when m is less than 100. What did we say here? Anytime m is less than or equal to 100, the cost is just what? Well, it should just be the $35, right? So when m is less than or equal to 100, we ditch this part altogether, and we get a cost of just $35. So this would be for m less than or equal to 100. This is what's called a piecewise function. So after I write my two equations, and remember this was just rewritten here, after I write my two equations, I would put them in this bracket to show that they both represent this situation, but there's two different scenarios here, okay? If m is greater than 100 or m is less than or equal to 100, okay? Okay, so now let's take a look at example 2. And this says determine the range of the function when the domain is the set of real numbers. We're looking at 2x squared plus 3. My issue with diving into this question in the very first lesson is that I think this is easier to do once you know how to graph these things. And technically, coming from Algebra 1, you should know how to graph these things. So if you want to jump on your calculator and graph that and look at it, you will probably have a better mental image of what this thing or what's happening here. I'm going to kind of talk through it algebraically. If I lose you, I'll circle back at the end and show you how to graph it, okay? So if the domain is all real numbers, all that's telling me is that I can plug anything I want in for x, okay? And in this type equation, there shouldn't be any restrictions on x, right? We can put anything into that equation for x. I have no limitations. What I'm asking is, what kind of numbers can I get out for y? All right, what answers can I get? And that's a harder question because you have to think about all of the different things that you could plug in place of x. So what I'm going to draw your attention to here is the x squared part of this, okay? Whatever I plug in for x is going to get squared. What kinds of numbers do you always get back as an answer when you square something? Hopefully you're thinking positive numbers, right? That even if I threw a negative number in there, when I square it, it's going to turn positive, okay? So this number right here, the x squared piece, has to be greater than or equal to 0, okay? That number that's going to come out of the x squared has to be, the lowest I could possibly get it to be is a 0, right? I can't get anything negative out of there. I'm going to double it, but that still is going to allow me to get 0 as a lowest possible answer, right? If I plug 0 in here and do 2x squared, I'm still going to get 0 out as an answer for this. So far, my range is anything above 0, or anything greater than or equal to 0, I should say. But then I'm going to take and I'm going to add 3. So even if I put in my very lowest number here and got this thing to equal 0, I'm going to shift that up by 3 when I do plus 3 here. So my range for this function would be all real numbers, because I can get anything out that I want. I can plug anything in that I want, which means I can get any number out that I want, as long as it's greater than or equal to 3. I'll never get a smaller number than 3 out of this function. You can start throwing some numbers in there and kind of experimenting and see what happens, but that is what you should notice, is that it'll be all reals greater than or equal to 3. Let me show you what I mean about using the graph, because I think the graph is an easier visual than what I just explained right here. So in your calculator, and just to remind you, you want to go to your y equals. I've got a bunch of junk in there. Let me clear all that out quick. Okay. I'm going to type in this equation. So I'm going to do 2, so you can see the buttons there. Here's my x, if you don't remember from last year. 2x squared plus 3, graph. You knew this was a parabola, right? I hope you knew it was a parabola. And you should notice that it's got this low point that is centered right at 3. Okay, that's what that 3 does to the graph, is it shifts it up by 3. You're going to learn all of that in the next chapter. But the lowest I can get is a 3. Now this thing's going to go up and up and up forever, okay, which is where the all real numbers part comes from, is it gets bigger and bigger forever, but you won't see anything, any y values that are lower than 3. That's the lowest point on the parabola. So for finding the range of functions, a lot of the times I like to rely on the graphs. I think the graphs are an easier way to go. Okay, so that does it for example 2. I'll throw some other videos in that kind of cover the rest of this lesson. This video everyone needed to watch, but the rest of the pieces of the lesson, if you feel like you've got them under control, you're probably okay to skip them. Okay, have a great day.